Tiangong Space Station, History, Present, and Future. The Tiangong Space Station represents a significant milestone in China's space exploration efforts. As the country's first permanent modular space station, it embodies a culmination of decades of advancements in space technology and international collaboration. This report provides a comprehensive overview of the history, current status, and future prospects of the Tiangong Space Station. I. Historical development. A. Experimental phases. Tiangong, 2011. Launched on September 29, 2011, Tiangong-1 was China's first prototype space station. It served as a laboratory for testing technologies for orbital rendezvous and docking, and for conducting scientific experiments. The spacecraft was visited by the Shenzhou 8 uncrewed and Shenzhou 9 crewed missions. Notably, Shenzhou 9 marked the first time an astronaut, Liu Yang, visited a Chinese space module. Tiangong-1 operated until it became uncontrollable and re-entered Earth's atmosphere on April 2, 2018. 2. Tiangong, 2016. Launched on September 15, 2016, Tiangong-2 continued the testing of technologies necessary for a modular space station. It was visited by the Shenzhou 11 mission, which remained aboard for 30 days. During this time, astronauts conducted a series of experiments and tests on weightlessness and human-machine collaboration. Tiangong-2 was deorbited on July 19, 2019, after completing its mission objectives. The construction of the Tiangong Space Station. Initiation, 2021. The construction of the Tiangong Space Station commenced with the launch of the Tianhe core module on April 29, 2021. This marked the beginning of a new era in China's manned spaceflight capabilities. Tianhe serves as the control center of the station, providing life support, navigation, and propulsion systems. 2. Completion of the basic configuration 2022. The Xuntian module was launched on July 24, 2022, followed by the Tiangong module on October 31, 2022. Their successful docking with Tianhe completed the basic configuration of the Tiangong Space Station. This configuration allows for diverse scientific research opportunities and long-term human habitation. Current status of the Tiangong Space Station. A. Structural overview. The Tiangong Space Station features a modular design consisting of 3 primary modules. 1. Core module Tianhe provides life support, navigation, and propulsion. 2. Laboratory modules Xuntian and Tiangong, equipped with numerous scientific instruments for research in microgravity conditions. The total mass of the space station is approximately 100,000 kilograms, with a habitable volume of 340 cubic meters. B. Ongoing operations. The Tiangong Space Station is currently operational and is continuously inhabited by crews of 3 to 6 astronauts. The station has hosted numerous experiments, including studies in biology, physics, and materials science, with over 1,000 experiments planned or underway. C. International collaboration. China has opened the Tiangong Space Station to international scientific collaboration, inviting experiments from various countries. Recent developments include partnerships with institutions from Europe, Asia, and beyond, aiming to foster a collaborative approach to space exploration. 3. Future prospects. A. Expansion plans. The China Manned Space Agency (CMC) has outlined plans to expand the Tiangong Space Station to include up to 6 modules. This expansion could enable more extensive research capabilities and increased astronaut participation. A significant addition is the planned launch of the Xuntian Space Telescope module in 2026, which will enhance astronomical observations and research. B. Commercialization and space tourism. CMSA is exploring avenues for commercial activities in space, including potential space tourism. The goal is to leverage private sector innovations to enhance the efficiency and capabilities of the Tiangong Space Station. See long-term vision. The Tiangong Space Station is designed for a lifespan of at least 10 years, with potential extensions to 15 years. It will play a crucial role in China's ambitions for future deep space exploration, including missions to the Moon and Mars. The station will serve as a platform for developing technologies necessary for extended human presence in space, laying the groundwork for future exploration endeavors. Conclusion. The Tiangong Space Station stands as a testament to China's advancements in space technology and international collaboration. As it continues to evolve, the station will not only enhance scientific understanding of the universe, but also inspire future generations to explore the final frontier. With ambitious plans for expansion and commercialization, the Tiangong Space Station is poised to play a pivotal role in the next chapter of human space exploration. The Tiangong Space Station Tiangong 空间站 represents a significant achievement in China's space exploration efforts, marking its transition from experimental missions to a permanent presence in low Earth orbit. Its history, current status, and future aspirations provide a comprehensive view of China's trajectory in space. History of Tiangong Space Station. In experimental phase, Tiangong 1号 launched on September 29, 2010, was China's first prototype space station. It served as a testbed for docking technologies and hosted several crewed missions, including China's first female astronaut, Lu Yang. It was decommissioned in 2016 after losing telemetry control and re-entered the Earth's atmosphere on April 2, 2018. Tiangong 2号 followed on September 15, 2016, providing additional capabilities for experiments and docking. It hosted the Shenzhou 11 crewed mission, contributing to China's experience in long-duration missions. It was deorbited on July 19, 2019, after completing its intended operational life. R. Development phase. The construction of the current Tiangong Space Station began with the launch of the Tianhe core module on April 29, 2021. This marked the start of a new era in China's space endeavors, focusing on a permanent modular space station. The subsequent launches of the laboratory modules Wentian and Mengtian in July and October 2020, respectively, completed the basic configuration of the station. Current structure and functionality. The Tiangong Space Station features a modular design with three main components. Tianhe Harmony of the Heavens, the core module that houses life support systems, navigation, and living quarters for the crew. Wentian Quest for the Heavens, a laboratory module dedicated to life sciences and biological experiments. Mengtian Dreaming of the Heavens, focused on microgravity experiments and materials science. The station is equipped to support 3 to 6 astronauts, depending on the mission duration and crew rotation. Its total mass is approximately 100,000 kilograms, with a habitable volume of around 122 cubic meters. Scientific and technological goals. The Tiangong Space Station is designed to facilitate a wide range of scientific research, including microgravity experiments that cannot be conducted on Earth, biological studies, such as growing plants in space, material science experiments to understand how materials behave in microgravity. The station also aims to advance autonomous docking and rendezvous technologies, enhancing China's capabilities for future deep space missions. International collaboration and future plans. One of the counterintuitive aspects of the Tiangong project is China's approach to international collaboration. Despite restrictions imposed by the U.S., notably the Wolf Amendment, which prohibits NASA from engaging with the Chinese space program, China has actively sought partnerships with other countries and space agencies. For instance, collaborations have been established with Europe, Russia, and several other nations for scientific experiments to be conducted aboard the station. Looking forward, the China Manned Space Agency CMSA plans to expand the Tiangong space station to 6 modules by 2017, including a next-generation space telescope, Xuntian, slated for launch in 2018. The expansion aims to increase the station's research capabilities and accommodate more international partnerships. Conclusion. The Tiangong space station not only symbolizes China's growing prowess in space exploration, but also serves as a platform for international collaboration in the field of science and technology. As it evolves and expands, the station is poised to play a crucial role in addressing fundamental questions about life, materials, and the universe, while also contributing to humanity's long-term goals of deep space exploration. The Tiangong space station represents a significant achievement in China's space exploration efforts, and its history, present status, and future prospects are rich with implications that many may overlook. Here, I will highlight some of the important aspects of the Tiangong space station, focusing on elements that are often underappreciated but have substantial significance. 1. Cultural influence and national pride. The naming conventions of the Tiangong modules reflect a deep cultural and historical context. The names Tiangong Heavenly Palace, Tianhe Harmony of the Heavens, Wentian Quest for the Heavens, and Mantian Dreaming of the Heavens carry significant cultural weight. The government's decision to use poetic and mythological names over technical identifiers was a strategic move to instill national pride and engage the public in the space program. This approach contrasts sharply with Western space programs, which often favor technical nomenclature. Significance. This cultural framing serves not only as a means of public engagement but also as a tool for fostering national identity and pride in technological achievements, especially in the context of China's historical narrative of overcoming external challenges and asserting its place on the global stage. The emotional resonance of these names can galvanize public support and interest in science and technology among the younger generations, which is crucial for sustaining long-term investment in space exploration. Technological innovations. The Tiangong space station has facilitated the development and testing of advanced technologies that are crucial for future missions, including those aimed at lunar and Martian exploration. The station's design and operational capabilities, including autonomous docking technology and life support systems, are derived from the experiences gained during the earlier Tiangong 1 and Tiangong 2 missions. One specific technological innovation is the use of Hall-effect thrusters, which are not only efficient but also represent a step forward in propulsion technology for crewed missions. These thrusters are designed to minimize the risks associated with traditional chemical propulsion systems, showcasing a commitment to safety and sustainability. Significance. The advancements made in propulsion and life support systems on the Tiangong space station will have far-reaching implications, enabling more complex and longer-duration missions beyond low Earth orbit. This positions China as a competitive player in the global space race, fostering an environment of technological innovation that could have commercial applications beyond space exploration. International collaboration and competition. Despite the political barriers posed by the Wolf Amendment, which restricts NASA from engaging with China in space endeavors, Tiangong has opened avenues for international cooperation. Collaborations with countries such as France, Sweden, and Russia, as well as with international organizations like the United Nations Office for Outer Space Affairs (UNOSA), highlight China's willingness to engage in scientific exchange. The selection of international experiments for the station demonstrates an interest in fostering global scientific collaboration. Significance: this aspect of the Tiangong program underscores the dual nature of international relations in space. While competition exists, especially between the US and China, there are also opportunities for collaboration in scientific research. The ability to conduct experiments in a microgravity environment can benefit global science, and the station may become a hub for international scientific endeavors, potentially reshaping global partnerships in space exploration. 4. Scientific research and experiments. The Tiangong space station is equipped with numerous experimental racks designed for various scientific disciplines, including life sciences, material sciences, and fundamental physics. Over 1,000 experiments have been proposed, showcasing the station's potential as a platform for groundbreaking scientific research. For instance, experiments involving the growth of plants in microgravity could have significant implications for food sustainability during long-duration space missions. Research on cancer treatment in microgravity environments also highlights the potential for advancements in medical science. Significance: the scientific output from the Tiangong space station could lead to breakthroughs that not only advance our understanding of fundamental scientific principles but also have practical applications on Earth. This research could inform future long-term human habitation in space, making missions to the Moon and Mars more feasible and enhancing our understanding of human health in space. Future expansion plans. The planned expansion of the Tiangong space station to include additional modules and functionalities, including the Xuntian space telescope, illustrates China's ambitious vision for its space infrastructure. The emphasis on a multifunctional station capable of supporting a variety of missions from scientific research to potential commercial activities like space tourism indicates a forward-thinking approach to space exploration. Significance: the expansion reflects not only an investment in scientific capabilities, but also a recognition of the growing commercial opportunities in space. By positioning itself as a leader in space tourism and commercialization, China may influence the future of the space economy, which could lead to new partnerships and economic benefits from space-related activities. Conclusion: the Tiangong space station is a microcosm of China's aspirations in space exploration, embodying technological innovation, cultural pride, and collaborative potential. While many may focus on the station's operational capabilities or its scientific experiments, the broader implications of its development culturally, technologically, and geopolitically are profound. Understanding these nuances is essential for grasping the significance of China's entry into the realm of long-term human space presence and its potential impact on global space dynamics. 4 valuable points for in-depth analysis and discussion on the Tiangong space station. 1. Historical development and technological progression. The Tiangong space station represents a significant milestone in China's space exploration history, building on the foundational work established by Tiangong-1 and Tiangong-2. The successful missions of these earlier prototypes not only enabled China to test critical technologies such as orbital rendezvous and docking, but also provided valuable experience in human spaceflight. The evolution from experimental platforms to a permanent modular space station underscores China's commitment to expanding its capabilities in space sciences and technologies. The timeline from the inception of these projects in 2011 to the completion of the Tiangong space station in 2022 illustrates a rapid advancement in engineering and operational expertise that can be analyzed in terms of project management, international collaborations, and technological innovations. 2. Scientific research and experimental opportunities. The Tiangong space station is designed to support a diverse range of scientific experiments across various fields such as life sciences, material sciences, and fundamental physics. With a total of 23 experimental racks and capabilities for both enclosed and exposed experiments, the station serves as a platform for conducting research that cannot be performed on Earth due to gravity constraints. The planned execution of over 1,000 experiments, including studies on microgravity's effects on biological systems and material properties, opens up discussions on the potential scientific breakthroughs that could arise from this research. Additionally, the inclusion of international experiments and collaborations highlights the station's role in fostering global scientific cooperation. 3. Future expansion and commercial opportunities. The future of the Tiangong space station is poised for growth, with plans to expand from 3 to 6 modules, including the introduction of the Xuntian Space Telescope module by 2026. This expansion not only aims to enhance the station's scientific capabilities, but also indicates China's strategic vision for long-term presence in low Earth orbit and beyond. Furthermore, the exploration of commercial activities, including space tourism, presents new opportunities for private sector involvement in space exploration. This aspect raises important questions about the commercialization of space, international competition in space endeavors, and the implications for global space policy. 4. International relations and space diplomacy. The establishment and operation of the Tiangong space station occur in a complex geopolitical environment, particularly concerning China's interactions with other spacefaring nations. The U.S. Congress's restrictions on NASA's cooperation with China have prompted China to develop its independent capabilities, reflected in the Tiangong program. Additionally, the station has opened avenues for collaboration with various countries, including agreements with European space agencies and joint experiments with international partners. Analyzing these relationships provides insights into the role of space exploration as a tool for diplomacy, the potential for conflict or cooperation in space activities, and the broader implications for international governance in outer space. These 4 points provide a comprehensive framework for discussing the Tiangong space station's historical significance, scientific contributions, future aspirations, and its impact on international relations in the context of space exploration. Here are 3 famous historical cases that bear similarity to the Tiangong space station's development and significance in the context of space exploration. In International Space Station (ISS). The International Space Station (ISS) is a collaborative multinational project involving NASA United States, Roscosmos Russia, ESA European Space Agency, JAXA Japan, and CSA Canada. Launched in 1998, the ISS serves as a microgravity and space environment research laboratory in which scientific research is conducted in astrobiology, astronomy, meteorology, physics, and other fields. Similar to the Tiangong space station, the ISS is modular in design, allowing various modules and components to be added over time. Both the ISS and Tiangong have been developed in response to geopolitical dynamics and technological ambitions, with the ISS representing Western collaboration in space, while Tiangong signifies China's independent advancements in its space program. Mir Space Station. The Mir space station was a Russian formerly Soviet space station that operated in low Earth orbit from 1986 until 2001. It was the first modular space station and was built from multiple interconnected modules, allowing for expansion and a variety of scientific experiments in microgravity. Mir served as a platform for international cooperation, similar to the Tiangong space station, which also aims to host international scientific experiments and collaborations despite geopolitical tensions. Mir hosted astronauts from various countries, and its legacy paved the way for the ISS, just as Tiangong may influence future collaborative efforts in space. 3. Skylab. Skylab was the United States' first space station, launched in 1973. It served as a laboratory for scientific experiments and for studying the effects of long-duration spaceflight on humans. Skylab consisted of a single module and was designed to be a temporary facility, which contrasts with the permanent and modular nature of the Tiangong space station. However, both projects aimed to push the boundaries of human spaceflight and explore the potential for living and working in space. The lessons learned from Skylab's missions informed future space station designs, including those of the ISS and Tiangong. Skylab's legacy as an early model of space habitation laid the groundwork for subsequent advancements in space station technology. These cases illustrate key milestones in the evolution of human space exploration, highlighting the technological and collaborative efforts that define humanity's journey into space. Future outlook for the Tiangong space station. As of 2025, the Tiangong space station has established itself as a key player in the international space community, propelled by its modular design, scientific capabilities, and ambitious expansion plans. The future of Tiangong encompasses a range of scientific, technological, and potential commercial endeavors, positioning it as a vital hub for space research and exploration. Expansion to 6 modules. One of the most significant developments anticipated for the Tiangong space